Hello. Today we'll be learning how to calculate areas of non-right triangles. To find the area of a non-right triangle, we generally use the formula 1/2 base times height. However, when we only have the lengths of the triangle's sides, we need to use a different approach. Let's discuss how to calculate the area of a non-right triangle using the formula 1/2 AB times sine C. Consider this triangle, ABC, where A, B, and C are the lengths of the sides, and C is the angle opposite side C. To find the area, we multiply half of the products of sides A and B by the sine of angle C. Now let's break down the steps involved in calculating the area of a non-right triangle using this formula. First, identify the lengths of the sides A, B, and the angle of C. Remember, C is the angle opposite the side C. In our example, A is 5 units, B is 8 units, and C's angle value is 45. The next step in using this formula involves calculating the sine of angle C. Using a scientific calculator or a trigonometric table to find the sine value of an angle, we can determine that the sine of 45 is approximately 0.707. Knowing this, we can substitute the values into our formula, multiplying 1/2 A times B times sine C, which we evaluated was 0.707. Computing the area, we can determine that the area of triangle ABC is approximately 14.14 square units. Now that we've mastered finding the area of non-right triangles using 1/2 AB times sine C, let's explore another method known as Heron's formula. This formula can be useful when we have the lengths of all three sides of a triangle. Here consider triangle XYZ, where X, Y, and Z represent the lengths of the sides. Heron's formula is the square root of S times, in this case, S minus X times S minus Y times S minus Z, where S equals X plus Y plus Z divided by 2. In Heron's formula, the area is calculated using the square root of the product of the semi-perimeter, which is S, and the differences between S and each side length. So in order to determine the area of this triangle, to begin, we must find the semi-perimeter, or S, by adding the lengths of all three sides and dividing by 2. In our example, X equals 6, Y equals 7, and Z equals 9. So 6 plus 7 plus 9 is 22, divided by 2 is 11. So in this case, our value for S equals 11 units. Now, we'll substitute the values into Heron's formula. Take the square root of S multiplied by each difference between S and the side lengths. From there, we can calculate the area. Plugging this into a calculator, we determine that the area of triangle XYZ is approximately 20.98 square units. Now that we've explored both 1/2 AB times sine C and Heron's formula, let's apply these concepts to a real-life problem. Imagine you are an architect designing a triangular park. You know the lengths of the three sides are 12 meters, 15 meters, and 20 meters. You need to calculate the area of the park to estimate the amount of grass that will be needed to plant. To solve this problem, we can use Heron's formula that we learned earlier, since we have the lengths of all three sides. Just to remind you, Heron's formula is the square root of s times s minus x, s minus y, times s minus z. First, let's calculate the semiperimeter, or the value of s, by adding the three lengths and dividing by 2. In this case, it's 12 plus 15 plus 20, all divided by 2, which equals 23.5. So in this problem, the value of s is 23.5. Now, all we have to do is substitute the values into Heron's formula. So the area will equal the square root of 23.5 times 23.5 minus 20, 23.5 minus 15, and 23.5 minus 12. Plugging that into a calculator, we determine that the area of the park is approximately 89.67 square meters. And there you have it. You've learned how to find the area of a non-right triangle using 1/2 AB times sine c, when to use Heron's formula, and even tackled a real-life problem using these formulas. Keep practicing, and soon you'll definitely be an expert in calculating triangle areas. See you next time. Bye.